Hello, in this video we're going to look at the cross-price elasticity of demand using calculus, and we'll do a couple examples. So the market demand for good X is given by the following equation. Q subscript X is a quantity demanded of good X. P subscript X is the price of good X, and then we have the price of a related good, P subscript Y, the price of good Y. We want to calculate the cross-price elasticity of demand. We're going to assume that the price of good X is $300 and the price of good Y is $200. I could have picked other values, but these are as good as any. So step one, we want to solve for the quantity demanded of good X at these values. So take this demand equation and plug in $300 for the price of good X and $200 for the price of good Y, and then just simplify it. And doing that, we get a value for Q 1,450 units. Step two, we're going to take the partial derivative, which is given by this notation. So we're going to take the partial derivative of the demand equation with respect to the price of good Y. And this is fairly easy. It's just going to be the coefficient on the price of good Y term. So 0.75, it's positive, so this is positive 0.75. Step three is we're going to put together the cross-price elasticity formula. And this is the formula right here. We need three things. We got one of those already. We got the partial derivative, which is 0.75. The next thing we need is the price of good Y. That's given to us as 200. And the third thing we need is the quantity demanded of good X, which we solved in step one. So putting all those pieces of information, these three pieces of information together, we're going to get 0.75 multiplied by 200 divided by 1,450, and we get a cross-price elasticity of positive 0.103. Since this is positive, this would technically be substitutes. Good X and good Y are substitutes with a positive coefficient. And the interpretation of this coefficient, a 1% increase in the price of good Y increases the quantity demanded of good X by 0.103%. So as the price of good Y increases, people will seek out substitutes. Good X, we said, is a substitute, so the quantity demanded of good X will increase from a price increase for good Y. All right, let's do another example. Here again, we got the market demand for good X. Quantity demand of good X is given as the following. Same definitions for the terms. We want to calculate the price elasticity of demand, assuming the price of good X is 100 and the price of good Y is 200. So as before, solve for Q subscript X by substituting these values into the equation. And you're doing that 500 minus 100 minus another 100 leaves the quantity demanded of good X at 300. Step two, we're going to take the partial derivative. So as before, all this is the coefficient in front of the P subscript Y term. This time it's negative, so we're going to bring that negative along here, so it's minus 0.5. The formula again is three things: the partial derivative result, the price of good Y divided by the quantity of good X. So making our substitutions here. Again, the quantity this time is 300, so that's down here in the denominator. So minus 0.5 times 200 is 100 divided by 300. We get a cross-price elasticity here of minus 1/3 or minus 0.333. This is a negative coefficient, so we're dealing with complements. And so in this case, good X and good Y are complements. A 1% increase in the price of good Y decreases the quantity demanded of good X by 1/3 of 1%. Okay, I hope you found this video helpful.